Welcome to my YouTube channel. In this video, we are going to discuss how to integrate integral of the form 1 over x plus 1, x plus 1 dx, how to integrate 5x minus 3 divided by x squared minus 2x minus 3 dx, how to integrate 6x plus 7 divided by x plus 2 squared dx, how to integrate the x divided by square root of 1 minus x squared, how to integrate 2x to the power of 3 minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3 dx. So from the technique of integration, here direct integral cannot be used because it's not of the form x squared. We cannot use integral by parts because it's not a product of two functions, dx, but in this case it's a fraction of what? Of polynomial function. Let's see if you can use partial fraction method to integrate 1 over x plus 1 dx. Before we use partial fraction to find the integral, we have to consider first it has to be a fraction of polynomial over a polynomial function. In this case, what is f of x? F of x is the numerator, which is 1. This is a constant function. Again, what is g of x? The g of x is the denominator, which is x plus 1. This is the same thing as x squared plus x. This is a polynomial of degree 2. Please watch my previous video on polynomial function. So to use partial fraction to integrate this, we have to check the numerator and the denominator are polynomial. Then we also check if the degree of f of x is less than the degree of g of x. If the degree of f of x is less than the degree of g of x, that is 1 over x squared plus x. Here, this is a constant function. The degree of f of x here is less than the degree of g of x. Again, we have to check the factor of g of x must be known in real linear. That is, it's not going to be in complex. Again, we also check if the fraction can be expressed as a rational sum of similar function. So to use partial fraction method to integrate, we have to check that the numerator say f of x. In this case, f of x is 1, and denominator say g of x. The g of x is x squared plus x are polynomials. The condition 1 satisfies this case. The degree of f of x must be less than the degree of g of x. Of course, f of x is even a constant function. The degree of g of x is 2 in this case. Then the factors of g of x must be known in real linear. X squared plus x can be rewritten as x plus 1. So this is what is saying, that the factors of g of x must be known in real linear, not in complex number. And the rational function, a quotient of polynomial, that is, this must be a quotient of polynomial, not in form of 1 over square root of a polynomial under here. Because of this square root, the denominator is not a polynomial. So if you have 1 plus x in this case, so this is not a quotient of polynomial. This is what this number 3 is saying, that the factors of g of x must be known in real linear, and the rational function a quotient of polynomials. So in this case, partial fraction cannot be used to integrate in this case. But here, they are quotients of polynomials, can be expressed as a rational sum of similar fraction. What he's saying is that 1 over x plus 1 can also be rewritten as a simpler fraction of a over x plus b over the second bracket. We call this undetermined coefficient, of which we will determine it, called method of partial fraction. That is what it means here. That what? Factors of g of x must be known in real linear, and the rational function can be expressed as a rational sum of simpler fraction. That is, this fraction can be rewritten as what? Another simpler fraction, of which we determine the a and the b. So since all the three conditions to use partial fraction to integrate satisfy this, we can go ahead and use partial fraction method to find the integral of 1 over x plus 1. So from above, what is this integral of 1 over x plus 1 dx? Did it satisfy the three conditions? So 1 over x plus 1, this is the same thing as a over the first factor plus b over the second bracket. Then from here, so the first step is to take the inside and equate it to what? An undetermined coefficient called a divided by the first plus b called the second over the second. Then if there is another bracket, then we say plus c over the third. But in this case, there is no third one. So the next thing is to what? Clear the fractions. We clear the fraction by what? Multiplying through by what? The denominator of 1 over x plus b multiplied by x plus 1 multiplied by x divided by x plus 1. This is the same thing as 1 equals to, this will reduce, we have a x plus 1 plus b x. So in this case, we open the bracket to be ax plus a plus bx. Then the next thing is to what? We have to equate the coefficient of corresponding powers of x. We have constant here. 1 is same thing as what? A, because a is a constant here. This implies that a is equals to 1. Then we don't have term with x here. We say 0 is equals to ax plus bx. In this case, x can never be 0, because when x is equals to 0, even this function will be what? Undefined. So there is no way x will be 0. This will imply that what? A plus b will be equals to 0 from this case, because we have 0 equals to a plus b into x. X can never be 0. 0 is equals to a plus b. This implies that a is equals to minus b. So a is equals to minus b. But we know that what? A is equals to 1. This will imply that what? B is equals to minus 1. We have determined that a equals to 1 and b equals to minus 1. So now we come back to here and substitute the undetermined coefficient a and b. This is the same thing as 1 over x minus 1 over x plus 1. So to integrate 1 over x plus 1 dx is the same thing as integrating 1 over x dx minus the integral of 1 over x plus dx, because when you is going to give this fraction. So to integrate here is same thing as integrating the right hand side. What is this integral? Ln x, because the derivative of ln x is 1 over x minus ln x plus 1, because the derivative of x plus 1 is 1 over x plus constant of integration. So the integral of 1 over x plus 1 dx is equals to ln x minus ln x plus 1 plus constant of integration. So from here, you can check that 1 over x minus 1 over x plus 1 is the same thing as what? X plus 1. When x comes here, it goes away and we left with x plus 1. When this comes here, we left with what? Minus x. This will go away. This is going to be 1 over x plus 1. So 1 over x plus 1 can be written as a simpler fraction of 1 over x minus 1 over x plus 1. That is what the third condition is saying, that the factors of the denominator must be known in real linear, and rational fraction can be expressed as a rational sum or rational difference of. So what is going to be the integral of 5x minus 3 divided by x squared minus 2x minus 3? So to use partial fraction to find the integral of this, we need to check that f of x the numerator and g of x the denominator are both polynomial. This is a polynomial of degree 2. This is polynomial of degree 1. Again, the degree of f of x must be less than the degree of g of x. In this case, degree of f of x is 1. The degree of g of x is 2. Here is less than 1. Again, and we check that what the factors of g of x is in real linear. The fraction can be written as a of sum of another fraction. What is it saying in this case? X squared minus 2x minus 3 is a quadratic equation of which it can be written as x plus 1 x minus 3. So 5x minus 3 divided by x squared minus 2x minus 3. This is the same thing as 5x minus 3 divided by x plus 1 x minus 3. So to integrate this function, we use partial fraction. So first we have to rewrite 5x minus 3 x plus 1 x minus 3 in a simpler sum fraction or different fraction, for which we have a divided by x plus 1 plus b divided by x minus 3. A and b are undetermined coefficients, for which the first thing is what? 5x minus 3, you have to clear the fraction plus 1, x minus 3 divided by x plus 1 plus b x plus 1 x minus 3 divided by x minus 3. This is the same thing as 5x minus 3 divided. This will reduce to be ax minus 3 plus b x plus 1. Then open the bracket. 5x minus 3 ax minus 3a plus bx plus b. The next thing is to what? Equate the corresponding coefficient of x and solve for a and b. So 5x is the same thing, is equals to ax plus bx. Then 5x is equals to a plus b x. X is equals to x, which is true. We have 5 equals to a plus b. In this case, a is equals to 5 minus b. Again, minus 3 is equals to any constant here, will equate it to it. Minus 3a plus b. Minus 3 equals to minus 3. We have a to be 5 minus b. This is 5 minus b plus b. We have minus 3 equals to minus 15 plus 3b plus b. This is the same thing as minus 3 plus 15 equals to 4b. 12 equals to 4b. This implies that b equals to 3, but from here we have a equals to 5 minus b. A will be equals to 5 minus 3, which is equals to 2. So the undetermined coefficient a is equals to 2 and b is equals to 3. So we can now substitute a and b here, that 5x minus 3 divided by x plus 1 x minus 3 is the same thing as 2 divided by x plus 1 plus 3 divided by x minus 3. So from here, to integrate 5x minus 3 divided by x plus 1 x minus 3 dx is the same thing as integral of 2 divided by x plus 1 dx plus the integral of 3 divided by x minus 3 dx. Remember that 2 is a constant, 1 over x plus 1 dx, plus 3 is also a constant, 1 divided by x minus 3 dx. What is this integral? This is 2 ln x plus 1 plus 3 ln x minus 3 plus constant of integration. So the integral of 1 over x plus 1 is ln x plus 1. When you find the derivative of this function, you are going to have 1 over x plus 1. The same thing here, the derivative of ln x minus 3 is 1 over x minus 3. The derivative of x plus 1 is 1 over x plus 1. So the integral of 5x minus 3 divided by x plus 1 x minus 3 dx is 2 ln x plus 1 plus 3 ln x minus 3 plus constant of integration. So from the previous example, we checked that when we check this fraction and we find the LCM as x plus 1 x minus 3 and we 2 x minus 3 plus 3 x plus 1 is going to give us this fraction. To find the integral of 1 over 1 minus x squared dx, first check. If you want to use partial fraction, check the condition of partial fraction. If it satisfies, you can use partial fraction to find the integral of this function. 1 minus x squared. Constant, polynomial. The degree of this is less than this. 1 minus x squared it has a factor in real linear as 1 minus x, 1 plus x. This is the factor of 1 minus x squared. So we can write 1 over 1 minus x squared to be a divided 1 minus x plus b divided by 1 plus x, because 1 over 1 minus x squared is equals to 1 over 1 minus x, 1 plus x. So now clear the fraction from 1 over 1 minus x squared, a over 1 minus x plus b divided by 1 plus x. 1 over 1 minus x, 1 plus x divided by a over 1 minus x plus b divided by 1 plus x. This is the same thing as ax plus 1 plus b 1 minus x. So what is this? 1 equals to ax plus a, open the bracket, plus b minus bx. Equate what? Coefficient of corresponding together. Constant is equals to a plus b. A is equals to 1 minus b. Again, what do we have? 0 equals to ax. Here, x can never be 0. 0 is equals to a minus b. This implies that a is equals to b. So look at the language. A is equals to b. When we add a and b, we have 1. What must a be? So in this case, since a is equals to b plus a equals to 1, we have 2a equals to 1. A is equals to half. A is equals to half. But from here, what do we have? B is also equals to half. Then from this condition, a plus b is equals to 1 over 2 plus 1 over 2, which is equals to 1, is true. So the undetermined coefficient is half. So integrate 1 minus x squared dx is same thing as integrating what? 1 over 2 divided by 1 minus x dx plus the integral of 1 over 2, 1 plus x dx. Because from above, this expression is same thing as this. A is half, b is half. To integrate this side is same thing as integrating this side and this side. Over 1 over 1 minus x dx plus 1 over 2 is constant, 1 over 1 plus x dx. This is same thing as 1 over 2 ln 1 minus x plus 1 over 2 ln 1 plus x plus constant of integration. We use this because we want this side to be positive because we don't have ln of negative number. So the integral of 1 over 1 minus x squared dx is 1 over 2 ln 1 minus x plus 1 over 2 ln absolute value of 1 plus x plus constant of integration. What is the integral of the x over square root of 1 minus x squared dx? In this case, to use partial fraction, f of x in this case is 1, g of x in this case is square root of 1 minus x squared. Remember that to use partial fraction, both numerator and denominator must be polynomial, but g of x is not a polynomial in this case, so we cannot use partial fraction method to find the integral of this 1 over square root of 1 minus x squared because the condition to use partial fraction fails. In this case, we are going to use trigonometry integral to find the integral of this 1 over square root of 1 minus x squared. Please watch my previous video. The integral of 1 over 1 plus x squared dx. In this case, to use partial fraction, check if the numerator and the denominator is a polynomial function. Also check if g of x has a factor in real linear. In this case, 1 plus x squared is not the same thing as 1 minus x. 1 plus x is not the same thing as 1 minus x. 1 minus x. Again, 1 plus x squared is not the same thing as 1 plus x. 1 plus x, because if you open this bracket, it's not the same thing as 1 plus x squared. 1 plus x squared has a factor in complex number as x plus I, x minus I. So this is a complex number. So the condition to use partial fraction to find the integral fails. We cannot use partial fraction to find this integral. Please watch my previous video. We use trig method to find the integral of 1 over 1 plus x squared. Find the integral of 6x plus 7 divided by x plus 2 square dx. In this case, to use partial fraction, because we cannot use by part trigonometry, we cannot use substitution method. So consider using partial fraction. We have to check that the numerator must be polynomial, the denominator must be polynomial. Again, we have to check that what the denominator has factor in real. Again, the degree of numerator has to be less than the degree of denominator. The degree of denominator is 1. This is polynomial of degree 1. The degree of denominator is 2 when you open this bracket. So the condition to use partial fraction satisfied. We are going to use partial fraction to find the integral of this function. But before that, we have to rewrite this fraction in a similar fraction. A over x plus 2 plus b divided by x plus 2, because this is x plus 2, x plus 2, as x plus 2, x plus 2. But mind you, since the denominator repeated, this is not how to do it. But let's assume this is how to do it, and let's find this expression. So clear the denominator. We have a x plus 2 squared divided by x plus 2 plus b divided by x plus 2, x plus 2 squared. Since the denominator repeated, this is not how to a divided by the first bracket, b divided by the second bracket, but just assume this and see what happens. This is 6x plus 7 equals to a, it will reduce the denominator, plus b, it will also reduce the denominator. This is 6x plus 7 equals to ax plus 2a plus bx plus 2b. Equate coefficients that are corresponding. We have 6x equals to ax plus bx. We have 6 equals to a plus b. 6 equals to a plus b. This same thing as 6 minus b is equals to a. Again, equate constant together, we have 7 equals to 2a plus 2b. This is same thing as 7 equals to, what is our a? A is same thing as 6 minus b plus 2b. 7 equals to 12 minus 2b plus 2b. You see, 2b will go away with minus 2b. 7 equals to 12, which is not true. So what we did here is not true. So the correct is what? When we have the denominator repeated as x plus 2, the undetermined coefficient divided by the first bracket plus the second has to pick all the denominator. This is how, when the denominator repeated, this is how to use the undetermined coefficient. The first is to pick the first bracket and the second undetermined coefficient will pick the both brackets. So from here we clear fraction. 7 equals to ax plus 2 plus, then we clear bracket, we have b only. This is same thing as 6x plus 7 equals to ax plus 2a plus, we are going to open the bracket as ax plus 2a plus b. Again, we equate a 6x equals to ax. In this case, a is equals to 6. Then we equate constant. 7 equals to 2a plus b. 7 is equals to 2a plus b. In this case, what is a? A is 6. We have 7 equals to 2 multiplied by 6 plus b. So this is same thing as 7 equals to 12 plus b. In this case, b is equals to minus 5. So the undetermined coefficient a equals to 6 and the undetermined coefficient b is equals to minus 5. So from here, plug in 6 here and also plug in minus 5 here. To integrate 6x plus 7 divided by x plus 2 square is the same thing as integrating 6 divided by x plus 2 plus the integral of minus 5 x plus 2 all square. So to integrate this left hand side, same thing as integrate here, where a is equals to 6 and b equals to minus 5. So this is the integral of 6 divided by x plus 2 dx minus the integral of 5 divided by x plus 2 all square dx. Remember that what 6 is constant. The integral of 1 over x plus 2 dx minus 5 is constant. The integral of x plus 2 square dx. So this is the same thing as 6 the integral of 1 over x plus 2 dx minus 5 the integral of x plus 2 minus 2 dx. This is 6 ln x plus 2 minus 5. Reduce the power over the new power, x plus 2 minus 1 over minus 1 plus constant of integration. So this is the same thing as 6 ln x plus 2. This negative will go away with this negative. 5 x plus 2 to the power of minus 1 plus constant of integration. Same thing as 6 ln x plus 2 plus 5 divided by x plus 2 plus constant of integration. This is the integral of 6x plus 7 divided by x plus 2 dx. Find the integral of x minus 1 divided by x plus 1 to the power of 3 dx. Look, the denominator is repeated, x plus 1 into 3 times. What is going to be? Remember that this fraction, we have checked that all the conditions to use partial fraction satisfy. Please, you can check. So to use integral by partial fraction, we have to rewrite this in a simpler fraction. A over the first bracket plus b divided by pick it 2 plus c divided pick all the denominator because it is repeated. You cannot pick it as x plus 1, x plus 1, x plus 1. It's just that you are repeating the same thing. So the first is x plus 1 to the power of 1, then you increase it, then you increase it if the denominator is repeated. So from here, we clear the fraction by multiplying this through. So you are going to have a x plus 1 square plus b, it will remain x plus 1 plus only c. What is this? This is x minus 1 equals to a x square plus 2x plus 1 plus bx plus b plus c. This is the same thing as x minus 1 equals to ax square plus 2ax plus a plus bx plus b plus c. So in this way, we are going to equate corresponding coefficients to find a, b, c. So x is equals to any term that have x. We have 2ax plus bx. So equate it together. We have x equals to 2ax plus bx. Then in this case, we are going to have x equals to 2a plus bx, 2a plus b. In this case, we have b to be equals to 1 minus 2a. Equate minus 1 to what? Any constant here. This is a plus b plus c. Again, 0 equals to any term that have x squared. This implies that what? X can never be 0. This implies that a is equals to 0. If a is equals to 0, what do we have here? We have b equals to 1. Then if a equals to 0 and b equals to 1, what is going to be this expression? Minus 1 equals to 0 plus 1 plus c. C will be equals to minus 2. So x minus 1 divided by x plus 1, same thing as a, pick the first, plus b, increase the power, plus c, then you pick all the denominator. We have found that a is what? 0. This term vanish. We have found that b is 1 over x plus 1 square plus c is minus 2 divided by x plus 1 to the power of 3. This is the same thing as x minus 1, x plus 1 to the power of 3. So to integrate x minus 1 divided by x plus 1 to the power of 3 dx is the same thing as integrating the right hand side, 1 over x plus 1 square dx minus the integral of 2 divided by x plus 1 to the power of 3 dx. So what is this integral? This is the same thing as the integral of x plus 1 to the power of minus 2 dx. Minus 2 is constant. X plus 1 to the power of minus 3 dx. Then reduce the power over the new power. Minus 2 reduce the power over the new power plus constant of integration. This is the same thing as minus 1 over x plus 1. This is the same thing as plus. Here will go away with this. 2 will go away. We have 1 over x plus 1 square plus constant of integration. So this is the integral of x minus 1 divided by x plus 1 to the power of 3 dx. Find the integral of x squared divided by x minus 1, x squared plus 2x plus 1 dx. What is this integral? To find this integral, you are going to check the condition of partial fraction for which f of x is equals to x squared polynomial of degree 2 and the denominator is a polynomial of degree 3. But look at the denominator. This is a quadratic equation. So before we can rewrite x squared divided by x minus 1, x squared plus 2x plus 1 in a simpler fraction, we have x squared plus 2x plus 1 is the same thing as x plus 1, x plus 1. So this is the factors of x squared plus 2x plus 1. What is going to be x squared divided by x minus 1? x squared plus 2x plus 1 is now equals to x squared divided by x minus 1, x plus 1, x plus 1. This is the same thing as x squared divided by x minus 1, x plus 1 all square. Repeated denominator. So to use partial fraction in this case, we have to rewrite x squared, x minus 1, x plus 1 all square in a similar form of a divided by the first plus b divided by the second, x plus 1 plus c divided by x plus 1 all square. Because this repeated, the first with this, the second we take x plus 1, and the third we take x plus 1 all square. Then clear fraction, equate corresponding coefficient, find a, b, c. So instead of integrating this, it's the same thing as integral of this dx, integral of b over x plus 1 dx, integral of c plus x plus 1 all square dx. Find the integral of z divided by z cube minus z square minus cz dz. In this case, f of z is a polynomial of degree 1, while g of is a polynomial of degree 3. We are going to check that what z cube minus z square plus 6z has a factor in real linear. So what is going to be the factor of z cube minus z square minus 6z? Z cube minus z square minus z is common. We have z square minus z minus 6. Again, what is this? This is a quadratic equation. We have to also find the factors of z square minus z minus 6. This is the same thing as z plus 2, z minus 3. So to integrate z divided by z to the power of 3 minus z square minus 6z, the z is the same thing as the integral of z divided by z plus 2, z plus minus 3 dz. But partial fraction, the integral of z divided by z plus 2, z minus 3 dz is the same thing as the integral of a divided by the first dz plus the integral of b to the second, because we have distinct denominator, plus the integral of c divided by z minus 3 dz. So you are going to find the undetermined coefficients a, b, c, substitute to this and find the integral. That is z over z, z plus 2, z minus 3. This is the same thing as a over z plus b over z plus 2 plus c divided by z minus 3. We have to clear fraction by multiplying through with z, z plus 2, z minus 3. It will reduce z. We have a to z plus 2, z minus 3. When this comes to this place, we have b. It will reduce the denominator to b, bz, z minus 3. Again, we have cz, z plus 2. The aim is to find undetermined coefficients a, b, c, z square plus, this is the same thing as plus 2z minus 3z minus 6 plus bz square minus 3bz plus cz square plus 2cz. So we have z equals to az square plus 2az minus 3az minus 6a plus bz square minus 3bz plus z square c plus 2cz. So z is equals to 2az minus 3az minus 3bz plus 2cz. 1 equals to 2a minus 3a minus 3b plus 2c. We have 1 equals to minus a minus 3b plus 2c. 0 equals to az square plus bz square plus cz square. So we have 0 equals to a plus b plus c. Question 1 here, we have 2 here. 0 equals to any constant minus 6a, any constant. A is equals to 0. If a is equals to 0, what do we have here? We have b plus c equals to 0, imply b is equals to minus c. So from equation 1, we have 1 equals to minus 3b plus 2c. We have 1 equals to minus 3b plus 2. C is equals to minus b. We have 1 equals to minus 3b minus 2b. 1 equals to b. This implies that b is equals to minus 1 over 5. So, but b is equals to minus c. C will be equals to minus 1 over 5, which is 1 over 5. So, in this case, b is equals to minus 1 over 5 and c is equals to 1 over 5. So the integral of z divided by z plus 2, z minus 3 dz is equals to the integral of a divided by z is gone, then b is minus 1 over 5, 1 over z plus 2 dz plus 1 over 5, the integral of 1 over z minus 3 dz. This is same thing as minus 1 over 5 ln z plus 2 in absolute value plus 1 over 5 ln z minus 3 plus constant of integration. This is the integral of z plus 2, z minus 3 dz. What is the integral of 2x to the power of 3 minus 2x squared plus 1 divided by x squared minus x? This is f of x, the numerator, and this is g of x, the denominator. Of course, f of x is a what? Degree 3, and g of x is degree 2. And by the criteria to use partial fraction, the degree of f of x has to be less than degree of g of x. So you are going to reduce the numerator in such a way that the degree of f of x will be less than the degree of g of x. So we are going to use the denominator to reduce the numerator. X squared minus x will be here. The highest power will be inside here, plus 1. X squared will reduce this. It will remain 2x. 2x multiplied by x squared, we have 2x to the power of 3. 2x multiplied by minus x is minus 2x squared. So we reduce it. Here will go away. Here will also go away. We are left with 1. So 2x to the power of 3 minus 2x squared plus 1 divided by x squared minus x. This is the same thing as 2x plus 1 over x squared minus x. That is 2x plus 1 divided by x minus x. Again, what is this fraction? This is the same thing as 2x plus 1 over x is common, x minus 1. So to integrate 2x to the power of 3 minus 2x squared plus 1 divided by x squared minus x dx is the same thing as integral of 2x dx plus the integral of 1 over x minus 1 dx. This is another partial fraction for which we introduce a to take the first and introduce b to take the second. This same thing as 2x dx plus the integral of a over x dx plus the integral of b over x minus 1 dx. We have to find the undetermined coefficients a and b. This same thing as a over x plus b over x minus 1. Clear fraction 1 equals to ax minus a plus bx. 1 equals to minus a. This implies that a is equals to minus 1. Again, 0 is equals to ax plus bx. X can never be 0. A plus b is equals to 0. But we have a to be equals to minus 1 here plus b. This implies that b is equals to 1. So the undetermined coefficients are a equals to minus 1 and b equals to 1. So from here, we are going to have minus 1 over x plus 1 over. When you find this, it's going to give 1 over x minus 1. So to find this integral here, substitute minus 1 here, put 1 here and find the integral of this. So the integral of 2x to the power of 3 minus 2x squared plus 1 divided by x squared minus x dx is the same thing as find the integral of 2x dx plus the integral of a is now minus 1 divided by x dx plus the integral of b is 1 x plus 1 dx. This is the same thing as what? 2 add 1 over the new power minus ln x plus ln x plus 1 plus constant of integration. This integral is x squared minus ln x plus ln x plus 1 plus constant of integration. This is the integral of 2x to the power of 3 minus 2x squared plus 1 divided by x squared minus x dx. To find the integral of y to the power of 4 plus y squared divided by y to the power of 3 plus y dy, this you cannot use by part to find the integral, and we cannot also use direct integral. Let's try to use partial fraction to find the integral. We have to use the denominator to reduce the numerator. We have to use the denominator to reduce the numerator. Here we are going to have y to the power of 3 plus y, and the highest power will be y will be here, y to the power of 4 plus y squared minus 1. So y reduce here, we have y multiplied by this, you are going to have y to the power of 4, y times we have y squared. This is same thing as this will go away, also here will go away, and we left with minus 1. So the fraction y to the power of 4 y squared minus 1 divided by y to the power of 3 plus y, this is the same thing as y minus 1 over y to the power of 3 plus y. So if you find this, you are going to get back this. So to find the integral of here, the same thing as finding the integral of the right hand side. But look at the denominator again. There is cube. We have to reduce the denominator. This is the same thing as y minus 1 over y is common, y squared plus. So to find the integral of y to the power of 4 plus y squared minus 1 divided by y cubed plus y dy is the same thing as find the integral of y dy minus the integral of 1 over y squared plus 1 dy. Again, we are going to use partial fraction to separate the denominator here. This is the same thing as the integral of y dy minus the integral of a divided by the first bracket dy plus b divided by the second bracket. But because here is square, we have to put y plus c here. This is how to find the integral if the denominator is square. Because if you did not put y here, we are not going to have the corresponding answer. So you are going to find the undetermined coefficients a, b, c. This is the same thing as a divided by y, by plus c divided by y squared plus 1. Clear fraction. 1 equals to a y squared plus 1 plus by plus c multiplied by y. Y equals to ay squared plus a plus by squared plus cy. Constant equals to a. Then 0 equals to any term that have y square, because there is no y square at this side. So we have 0 equals to a plus b. Y can never be 0. This implies that a is equals to minus b. So again, 0 equals, there is no term that have y here. So 0 equals to cy. This implies that c is equals to 0. Y can never be 0. From above, a equals to 1. Again, a is equals to minus b. This implies that b is equals to minus 1. So this implies that b is equals to minus 1. So from here, a is now 1. We plug in 1 here. We plug in 1 here to find the integral. B is equals to minus b, which is what? B is minus 1. In this case, we plug in minus 1 here. But this case here is 0. This is going to vanish. And we're going to have minus y over y squared plus 1. So this integral is going to be the integral of y to the power of 4 plus y squared minus 1 divided by y to the power of 3 plus y dy is equals to, here is what? The integral of y dy minus a is 1 over y dy plus b is minus 1 multiplied by y. C is 0 divided by the integral of y squared plus 1 dy. So from above, a is equals to 1 and b equals to minus 1. Substitute here. The integral of y dy minus the integral of 1 over y dy minus c is equals to 0. The integral of minus y over y squared plus 1 dy. What is this integral? Add 1 to the power over the new power minus ln y. Here is going to be plus. Use substitution here. If you let, you are going to, then the u over the y will equals to 2y. And the u over 2 will be equals to y dy. So this negative will go away with this negative. The integral of y dy is now du over 2 divided by u. So this integral is what? Y squared divided by 2 minus ln y plus 1 over 2 is a constant. The integral is what? Ln u plus constant of integration. This is the same thing as y squared divided by 2 minus ln y plus 1 over 2. What is what? U. U is y squared plus 1 plus constant of integration. So this is the integral of y to the power of 4 plus y squared minus 1 divided by y to the power of 3 plus y dy. Find the integral of 2y to the power of 4 divided by y to the power of 3 minus y squared plus y minus 1 dy. In this case, degree of the numerator is bigger than the degree of the denominator. This is improper fraction. So you are going to use the numerator to reduce the numerator. Y to the power of 3 minus y squared will reduce 2y to the power of 4. We left with 2y. 2y multiplied by y 2y to the power of 4 minus 2y multiplied by minus y squared. This is minus 2y to the power of 3 plus 2y squared minus 2y. Then we subtract. Here will go away. This negative will enter. We have 2y to the power of 3 minus 2y squared plus. So again, you are going to reduce the go here. We have plus 2. 2 multiplied by y, we have 2y to the power of 3 minus 2y squared plus 2y minus 2. Will go away. Here will also go away. We also have here to go away, and we left with plus 2. So in this case, 2y to the power of 4 over y to the power of 3 minus y squared plus y minus 1 is the same thing as 2y plus 2 divided by y to the power of 3 minus y squared plus y minus 1. Look, the denominator come with cube again. We have to the denominator in such a way that it will come with just to the degree 1 to the power of 1. So what is this? In this case, we are going to find another factor of y to the power of 3, y to the power of 2 plus y minus 1. In this case, y equals to 1 is a zero of this expression. That is, when we plug in y equals to 1, we are going to have 0. That is why we say y equals to 1 is a zero of this y to the power of 3 minus y squared plus y minus 1. So y minus 1 is going to be a factor to use in this case. Y minus 1 to reduce y cubed minus y squared plus y minus 1. So y equals to 1 is a zero of the denominator. Y minus 1 is a factor of the denominator. We are going to use y minus 1 to reduce y cubed minus y squared plus y minus 1. Y will reduce here. We have y squared. Y squared multiplied by y, we have y cubed minus y squared. Reduce. We have 0. Here will be 0. And we are left with what? Y minus 1. Y divide here, we have plus 1. 1 multiplied by y minus 1. Then we reduce. It will go away and we have 0, 0. So in this case, y cubed minus y squared plus y minus 1 is the same thing as y minus 1, y squared plus 1. So from this expression, I'm not going to write y cubed minus y squared plus y minus 1. I'm going to write y minus 1, y squared plus 1. So the integral of 2y to the power of 4 divided by y to the power of 3 minus y squared plus 1 dy is the same thing as the integral of 2y dy plus the integral of 2 dy plus the integral of 2 divided by y minus 1 y squared plus 1 dy. So you are going to also use partial fraction to separate the denominator here. This is what the integral of 2y dy plus the integral of 2 dy plus the integral of a over the first bracket dy plus the integral of the second, because here is square, bx plus c divided by y squared plus 1. There is no other factor of this again. That is why we are having it to be the denominator like this, and we moderate the numerator with this variable. So to determine a, b, c now, that is 2 over y minus 1 y squared 1 is the same thing as a y minus 1 plus by plus c divided by y squared plus 1. This is from here. So clear fraction, we have a to be what? Y squared plus a, because here we'll go away with this and we are left with this. Then you open the bracket plus here we'll go away with this and we are left with what? By square minus cy minus by minus c. We are going to what? Equate 0 will be equals to any term with square here, by square. 0 will be equals to a plus b. So in this case, we have a equals to minus b. Again, any constant here, 2 is equals to a minus c. This implies that what? C is equals to a minus 2. Again, we are going to have any term with is going to 0 equals to minus cy. This implies, so from this expression we have a equals to 1, b equals to minus 1, and c equals to minus 1. You can do it on your own. Equate constant with any constant with any constant. Then no term with y square here. Put it to be 0. Equate it with this, equate it and find. Then no term with y here. 0 equals to, equate it with this and also this. You are going to find that a equals to 1, b equals to minus 1, and c equals to. So the integral of 2y to the power of 4 divided by y to the power of 3 minus y squared plus y plus 1 dy is equals to the integral of 2y dy plus the integral of 2 dy plus the integral of a divided by 1 minus 1 dy plus the integral of by plus c divided by y squared plus 1 dy. So we have found a, b, c in this expression. 2 dy plus the integral of 1 over y minus 1 dy plus the integral of minus y plus 1 divided by y squared plus 1 dy. C, b is minus 1. So this is the same thing as the integral of 2y dy plus the integral of 2 dy plus the integral of 1 over y minus 1 dy minus, we can separate the integral of y over y squared plus 1 dy, integral of 1 y squared plus 1 dy. Divide by y squared plus 1 is same thing as minus y divided by y squared plus 1 minus 1 over y squared plus 1. What is this integral? Add 1 to the power over the new power plus y plus ln y minus 1. Here, I'm going to use partial fraction. We did it before. To let u be the denominator, differentiate it with the respect of y. Then you are going to find here to be 1 over 2 ln y squared plus 1 ln y squared plus 1 plus constant of integration. So the integral of 2y to the power of 4, y to the power of 3 minus y squared, y to the power of 2 plus 2y plus ln y minus 1 over 2 ln y squared plus 1 ln y squared plus 1 plus constant of integration. Thank you very much to follow up from the beginning of partial fraction integral to the end. I'm very grateful. Kindly subscribe for more video. In the next video, we are going to start with number system and say how to plot graph.